All right, length of string 2. So we've done length of string before. This is just a type length of string that calculates the length of a template string. The difference here is that it has to support several hundred characters long. So let's just jump in. I'll show. So here it is. I didn't even bother trying to make this fit on the screen because I think you can see the difference. Let me grab length of string that we had originally. So there's this. I mean, well, maybe not, because I actually think the one that we made may have passed, so I don't want to give it away. I will say, like, we can do extend string there because why not? The most common, like, first approach to this is to do this.
T length, because otherwise, does that not work?
It doesn't work. No. So let's check out. I wish to see. This is why I like having. Let's do this. Let's do this. We'll grab this one. We'll grab something like and make a little scratch pad here. Type X equals this. And if we hover over X, we see that it's just number.
Oh.
So
well, that's not fun.
That doesn't work because they're not, like, at that point when you're accessing T, they're not literal values. There is a trick.
Right, it's that string here, yeah.
Right. So I'm gonna flash put this on the screen and see. Okay, this is fine. So there is a trick, and this is our solution. Chandler, you didn't do this with me, but someone, I think it was Upender, we did this one together. This is the solution in the easy section. I think we're into hard now, difficulty. It works by creating a tuple from the string, and the tuple is just grabbing the first value and then recursing.
That's lame, cheating. Well thought out.
It is. Yeah. I mean, it works kind of, but once you get
right, it's not cheating because it works, and the other way doesn't work.
But once you get to a certain level of recursion, and I mean, it changes from TypeScript version to TypeScript version, but it's like I think it's around 45 or maybe 100 right now. Once you get to that stage, it stops working and you kind of get stuck. Right. So you have to find another way to solve this. What would, instead of, there is a cheatier way to solve it. I think actually in this case, can I just show you the solution instead of, because this one isn't really like something that you
can't do math in TypeScript, so I'm a bit stumbled.
I don't think this is one that you can, I guess I didn't tell you this. I think the last one was the first hard one that you and I did together. As my policy for the challenges is like the easy ones, you're on your own. The medium ones, you get tons of help. The hard ones, you can try it if you want. And the extreme ones, like it's basically going to be a presentation of the solutions. So I'll show you one of the solutions. Here we go. This one is interesting because it skirts around the recursion in an interesting, let me do, I turned on word wrap. It skirts around the recursion in an interesting way. So we have S, and S is an alias for string just because it would be like 1,000 characters long. Otherwise, you could just put string in here. That doesn't really matter. But T takes an accumulator, which is a counter accumulator. We've seen this kind of thing before. You can put, for all the places where it says 1 here, you could put like, I don't know, cat. It doesn't matter. Everything still passes. So we're just making an accumulator that has like, it's just a counter basically. And then we're seeing if T extends an array with like this many things in it. And we could put more in here. Like I could copy and just keep putting more in here and it will continue to pass. Actually, all that we do when we get that is get a higher level of recursion. What's the error we're getting here? False does not satisfy the constraint. Okay, so we could go pretty far with it. Let's back up a little bit. Oops. TypeScript, when you do big challenges or challenges that have a lot of recursion like this, sometimes the TypeScript language server will crash. But then at the end of the day, it does basically the same solution we saw before. So it's globbing like 10 strings or 15 strings at a time, you see? Mm-hmm. And then at the end of it all, it will bring them together by doing like the 1 by 1. So if T doesn't, like reading down the line, I'll turn off word wrap for a second. If T doesn't extend this, then we get here. And what is this? This is basically the solution I just showed from the easy set or whatever, medium challenges. And it grabs the length. The final base case of the recursion is to grab the length of the accumulator. And that's our number that we return. So that's one solution. I'll commented it. Here's another solution, which is much more elegant. This one is going like one by one through length of string, and it's creating the accumulator that way. I'm not really clear on why this works in the thing that we saw a couple seconds ago. Like here, let's put them back to back next to each other. It's not remarkably clear to me why this one on top fails and the one on bottom works, because they feel roughly similar. The thing that I'll say is that in TypeScript, the recursion level for strings seems to be much, much higher and than the recursion level for tuples and arrays. And I don't know why that is, but this works because of that. So a lot of the challenges...
The only way to handle strings is that recursion, but otherwise they just pick an arbitrary depth to stop a type recursion into another type.
Maybe, yeah. I mean, it turns out that a lot of the challenges... There are challenges that allow you to add like 1 million to 10 million, and it works. And the way that those all function is by creating like basically a base 10 register for each digit of the, like for the zeros, the ones place, the tens place, the hundreds place, the thousands place, so forth, and using strings to do the addition.
Right.
Yeah. So there is oh, and that's it. That's okay. That's it. That's the end. So yeah. Any thoughts on this one?
I've hit things like this in the past, and I've always wished TypeScript allowed math and had logic for that. I don't care for the accumulator strategy, but hey, again, it works.
It's the only way.
Gross. Yeah. You never need it.
Right. There's no other path. I think like sum, it like, you know, as in simple addition is one of the extreme challenges. It's so funny. You can do all these funny things, but you know, adding 1 and 1 is not really something that's possible in TypeScript. I mean, it's possible, but you have to like, there's a lot of tricks you have to do to make it work. It is possible, but you have to like
take it out of numbers first.
Yeah, you end up creating counter, just like we did here. You end up creating counter tuples and then like spreading them together and checking their length, and like you end up doing stuff like that in order to make it function. So, cool. All right, let's keep going.
It's also interesting here that the string length is just number, but TypeScript cares about array lengths much more.
Mm-hmm. Yeah, it's very sensitive to array lengths, and it will give you their literal values, or tuple lengths, we should say, because array lengths, the value is number.
Yes, that's fair. Yes.
But yeah, it is interesting that you have to be aware of all these little tricks in order to make something like this function. But yeah, cool. All right, let's keep moving.